All right, here we go. So let's work our way through the plate boundaries. Welcome, everybody. We're going to start with divergence, which means that the crust is being pulled apart, right? So you got to keep those straight. That's going to be hopefully the easy part. Crust is being yanked on. What we call tension is being pulled. Specifically, because we got to do two types of these, as noted. And if you didn't watch the intro to this, go watch that. That note sheet goes in this order deliberately. Oops, convergent. Hello. Divergent, Continental. And we also said we want to look at where they're happening, which means I got to pull up Google Earth. All right, we got it. So what I'll do for each of these is like what's the textbooks like section where this is really going on? Are there other places? Yeah, but like when it comes to like here's the one that's exactly the spot, we're going to look at the East African Rift Valley. So this yellow line that goes down through East Africa with this section heading that way relative to this section over that way. You can see if I turn it off, you can almost see it if you can kind of visualize that valley right there and then where all these lakes lie. Water flows downhill, so it's going to go to the low areas. The low areas are created when the crust opens up like that. Right down through there. There's cool videos of places where this is like expressed on the surface, farmers' fields that are just like being rifted right open. So let's draw it. So this is going to be like a couple of steps. Now, it's your call how you want to do things. Do you want to get out some paper and do it along with me? Obviously, I'm not checking up on you. So let's go with having some lithosphere here. And as indicated, we're going to have tension. So like pizza dough, if you put it down on the counter and you start to spread it out, what happens to its thickness, right? It gets thinner and thinner and thinner. Where that's a bad analogy with this is that pizza dough deforms, kind of mushes out. Lithosphere, as discussed earlier in this section of class, is brittle. It can only crack. So as it starts to go, this will be like phase one right here. As it starts to go, we'll draw that thicker oceanic crust. I'm sorry, thicker continental crust. And you're going to get this type of fault. These are drawn, I mean, by somebody who's terrible at drawing like me using a mouse, but still drawn with some degree of accuracy for how this would look, these down-thrown blocks. All right, so there's your, what we would call a rift valley. And maybe I should take a step back too. What the heck are we drawing here? We're drawing cross sections. So this is like map view. If I could go down into this and like pick up the earth and look at it from the side, what would it look like, right? Now I can't actually do that with Google Earth. If I could like slice into it, lift it up and say, what am I looking at from the side as this thing forms? That's what we're drawing. We're drawing these in cross section. So this is just good old plain old crust. I mean, sometimes when I'm working with students, I'll say, draw like some trees or a house up there. This tree is ridiculously large out of proportion, not even close to right. But just to say that, like, here's the surface, here's working down into the earth, here's our lithosphere. Down below will be the asthenosphere, and maybe there's some convection in the asthenosphere that's like helping drive this. There's other tectonic forces too. But in some scenarios, this will help drive that opening. Then as it opens and cracks because it's brittle, you form your rift valley. Down here, you'll get geothermal activity. You'll get volcanoes. We can draw, again, it's tiny, but it's ridiculously large out of proportion. Volcanoes that may go off in this valley. Okay, that's really it. You start to get that tension on the crust. It starts to open up, and you'll get that. Now, again, there's today. Let me zoom back out. Today, this is going on right here. What we're going to do for video number 2 then is I'm going to keep the same thing going. I just want to do separate videos so everybody can watch it a chunk at a time. I'll pick right back up. What would this look like? So do it in your head. What would this look like if we played it and fast forward for 100 million years? And there's kind of a preview right there. This would have been rifting at one point, just like down here on land, but now it's open enough that it's low enough that the ocean has intruded. Or play it forward here, what's going to happen is this goes up and the ocean may intrude. These things tend to happen in threes, 120 degrees apart, and then one of them fails and two will continue. So beginning of the next video, we will look at one right over here, hint, hint, that happened about 200 million years ago with the opening up of that ocean. All right, so there's rift valleys. Check it out. With all of them, I'd say check out some other sources. Look it up in the textbook. Look it up in, just search for rift valleys, cross sections, see what you find. Look for similarities, and we'll see how it goes. Let me pause quick and just make sure we hit the whole chart. Yeah, I think we're looking good. Just to throw it out there, this is the thing I'm talking about. I don't necessarily want to fill it out for you guys if you watch a video. I think you hopefully picked up on all of that. So that'll wrap up that one. We'll pick up Divergent Oceanic in a moment. Thanks for tuning in.